Hello, good evening everyone. My name is Ishimito Mogdan Quizon, and so this is the report of Group 2 about the related rates example 2. Together with me is Mr. Divan Montes, Mr. Luis Cesar Tampipe, Ms. Kirsha Balaba, and Ms. Shenmei Abadonado. Hope you enjoy our presentation and hope you will learn something out from it.
The problem is that a man 167.68 centimeter tall is walking directly away from a lamppost fronting a building at the rate of 91.46 centimeter per second. If the lamp is 8 meters above the ground, find A. The rate at which his shadow is lengthening, and B. The rate at which the tip of his shadow is moving.
So for us to better understand the problem, we have to draw the figure first. So it is stated there that the man is 167.68 centimeters tall and is walking directly from a lamppost. And so the lamp must be behind the man and it should also be 8 meters above the ground. So we have the figure there, and so let S be the length of man's shadow, X be the distance of the man from the lamppost, ds over dt is the rate at which the man's shadow is lengthening, dw over dt is the rate at which the tip of the man's shadow is moving, and dx over dt is the rate at which the man is moving away directly from a lamppost.
Problem A. As what we can see in the figure 3.8, the building with a post, a man, and its shadow. We can compare it to this right triangle with a small right triangle inside. With that, we can use the trigonometric identity tangent, which is opposite over adjacent, to our two right triangles. Now, from the small triangle, by using the opposite over adjacent, we have S over 167.68 is equal to the other triangle, the bigger triangle, X plus S over 800. We have here 800 because we converted 8 meters to centimeters, which is 800. So, by similar triangles, we can find the rate at which the man's shadow is lengthening. Now, we will just perform the operation. We cross multiply this and this. Now, we have 800s equals 167.68x plus 167.68s. Now, we add both sides with negative 167.68s in order to remove the ones in the right side. We have now 800s minus 167.68s equals 167.68x. Then we subtract this one. We will have the result of 632.32s. Then we can divide both sides with 632.32 to extract the value of s. Now we have s is equal to 167.68x over 632.32. Finally, we have here the value of s, which is 0.27x.
Thank you, Divan. Next, we will differentiate s with respect to t, as we have dx over dt equals 91.46 centimeter per second. Now we have here ds over dt equals s times dx over dt. So ds over dt equals 0.27 times 91.46 centimeter per second. Now, we have ds over dt equals 24.69 centimeter per second.
So, after getting the rate at which the man's shadow is lengthening, let W equals to x plus s because W is equal to the total value of x and s. Notice that the man's shadow is moving in a line, so we differentiate W with respect to t to get dW over dt equals to dx over dt plus ds over dt. So, we have an equation on which we already have values.
Now we have to differentiate W with respect to t. So we have dW over dt equals dx over dt plus ds over dt. In finding dW over dt, we only have to use the substitution method. Since ds over dt is equal to 24.69 centimeters per second obtained from the previous problem, letter A, and dx over dt is 91.46 centimeters per second from the given, then we can just plug in the said values. By just adding 24.69 and 91.46, we can get 116.15. Thus, the rate at which the tips of man's shadow is moving is 116.15 centimeters per second.
And that would be all, everyone. Thank you for listening and have a good night.